Next episode of the AV Experience. I'm your host, Ryan Charpentier from Ascend Audio Video, joined by the now back Ben
And
Goff.
awake.
And awake. Yes, he got back and he was tired. And I would be too after that much travel. You were working. I mean, it's always fun to travel on those trips, but it's still a work trip.
Yeah, the travel back was long. I made the decision not to fly via the Middle East just because I didn't want to get stuck if things changed. So the route we took home was 32 hours.
Oh,
it was yeah, can't complain, right? We went and hung out in
sticky where you were.
Sorry.
Was it hot and sticky?
So we missed the entirety of the UK summer. The UK had no more than 5 or 6 days of summer per year. And that was the week that we were away. So that was great. But it was still then hotter and more humid and more rainy all at the same time where we were. So I could complain, or I could just accept that I was in possibly the best private cinema ever built on the face of the earth. And it was incredible. And I had a great time sitting, calibrating it and playing with it. So
good.
I could moan, and maybe I shouldn't, right?
Yeah. I mean, you can still complain, not about that space, but about the weather, what have you. I mean, that's human nature.
Yeah. Yeah, it was warm. Long days. It's we were doing probably 14 hours a day on site. It was long. It was a long trip, but
oh my gosh.
Back, awake, happy, good.
Good. Well, couple of quick housekeeping details. One, I do have a customer that is looking to unload a Storm Fusion. It is a used piece. If you have any interest in that, please shoot me an email down below. If you have any need for, trying to find homes for any type of equipment, feel free to shoot me an email and I can post them on this stream or at least talk about them.
So hey, if we're playing that game, I've got to interject because I've got a Barco Freya that desperately needs a home.
Well, there you go.
If we're playing that game, it can go anywhere in the world.
No,
I need a home for that Freya.
The only thing we will not do if we do stuff like this is we will not talk about pricing. We will talk about pricing if you message us, but we will not talk about pricing on the stream. Some of this equipment, the vendors do not like pricing being discussed. They graciously allow us to say that things are for sale, but they don't like us talking about pricing. So you will have to message us in order to get pricing on that equipment. You can email Ben or I. Our contact details are down in the descriptions. Another thing, Ben mentioned after he got back, and I agree, this is something I've been wanting to do for a while. He said, why don't we review spaces like theaters, multimedia spaces, whatever? I thought that was a great idea. So we're going to start doing it. I actually am finishing a form that people can fill out and they can submit their space for review. And this is going to be us talking about it. It will probably be us just be aware we're probably going to be brutally honest, positive or negative.
Right.
So it's not that we're trying to be mean. It's constructive criticism.
Right. I think that's the thing. We get asked loads of questions of, what's the next upgrade? What should I do next? This is a slightly more formal way to do that. Tell us about the room. Show us photos of it. Give us a kit list. Let's see where you're at. And then we can give a proper constructive discussion of what's working really well now, what you could do better, where you can go. And I think that will be quite fun for people to see. And it's not going to be about being rude. It's going to be about being honest.
Yes. It's about making things better if possible. And Ben and I are absolutely not the end all be all. And if we don't have the answers, we will seek out the answers potentially for you or gain the knowledge that we can share back with you. But we thought it would be interesting because we talk about this stuff all the time and people are always, hey, I've got this space. If I did this, well, why don't we start this where we're going to talk about a room an episode or a couple of rooms an episode, depending on how granular this stuff gets. But we thought that would be a great idea. So I'm going to submit a Google form that people can fill out and we can get some spaces to do this on. I have no idea where it's going to go, but I thought it was a great idea. So we're going to go with that. Now, our topic. We did not prep for this, as is the way on the AV Experience. So we'll see if we stay on this topic. But Ben suggested quiet.
I didn't. I'm not going to take responsibility for this.
You did.
I was sat with Peter about half an hour ago saying, I need to text Ryan and see what we're talking about today because we've not discussed it. I look at my phone and see you text me to say, "What are we talking about today?" So I asked Peter, and Peter said, "Why don't you do quiet?"
Yeah,
So that's where we're at.
quiet is not talked about enough on this stream, this podcast. So I think it is something that need be discussed, that need really brought into the limelight, if you will,
Right.
because I think it's much more important than people realize. Now there are extremes to this, like anything where it does cost exponentially more money in order to
Right.
reach smaller and smaller gains as
Quiet
it
costs
fall
more than
further
loud.
down.
That's a starting point. It's definitely more expensive than loud.
Yes.
Loud, if you choose the right kit, you're gonna be able to go loud. That's
Mhm.
just easy.
Mhm.
So I guess quiet really comes from, how we work as a business, and like there's a lot of what we do in that like I'm happy to teach people all the AV side of this, because ultimately the AV part is quite easy. Quiet isn't. Quiet's hard. It's difficult to do.
Yeah. Yeah, I do think there's some things that matter quite a bit more, and there's some things that you don't necessarily have to spend as much on in order to eliminate them. But
Right.
it also depends how far down that rabbit hole you're trying to fall, right? When we're
Yeah.
talking about quiet, in a lot of these, what we're using as an examples are extremes, where your measurement mic in a lot of situations, and this isn't as extreme as you may think, you're gonna pick up the noise floor of the measurement mic or whatever microphone you're doing before you're gonna find the noise floor of the room. And
Yeah.
that can lead, just a quick tidbit, to a misinterpretation of what quiet means, because some people may not realize that. Actually, I think a lot of people may not realize that when they're in a quiet room and they're like, "Oh, my room's only this dB." That's not really true. It's if you're in a really quiet room, it's probably quite a bit
Yeah.
quieter than that.
And that's not easy to measure. So we're
It's expensive to
using
measure.
we have 2 microphones that are basically just used for the background room noise,
Yeah.
and you put them face to face as a pair, kind of 1 millimeter apart, and they're cross correlated. So anything that one hears, if the other hears the same thing, that stays in the measurement. Anything that doesn't correlate is classed as noise in the measurement system. So from the preamp or the microphone, if those 2 microphones are 1 millimeter apart and they pick up something different, that can be cancelled out. And then you average this over maybe 2-3 minutes. So you're taking hundreds of correlated measurements and only keeping the things that both microphones heard. And
Mhm.
there's no other way, without spending, lab grade tens of thousands of dollars. There's no other way to measure actually a low noise floor,
Yeah.
properly low.
Now, that's how you do it, at least how you do it. What is a good place for people to start? Take the average homeowner,
Right.
right? What is a great place for people to start when they're trying to make a space quieter?
So I guess from an experience, that starts from content. So if we think of Quiet Place,
Mhm.
we
That's a
we
great
call the
example.
scene we call the scene "Mind Out for the Step," I think it is, or "Watch Your Step." We don't need to discuss the graphicness of this
No.
scene, but there's a alarm clock ticking, panned hard left. If you can't hear that alarm clock beautifully clearly above the noise floor of your room, then you're losing a really important emotive part of that scene.
Well, I think if you can't hear that alarm clock, you have a catastrophic problem with noise floor in your room.
Sure, I know people who hang projectors above their main seats.
Yeah, but I
So
think I do too, but even then, a quiet projector won't mask that sound. A moderate to loud projector absolutely will if it's
sure,
put above you.
sure, and it's not about masking it, it's about distracting from it. So if I
Yes.
take another one, right, take the opening scene of Alex, I've just forgotten his name, Civil War, but not the superhero version, the good one, right? The one that's actually a
Yeah,
good film.
yeah.
Um, Opening scene of that, explosion goes off. You immediately essentially get the character's hearing loss. So it just drops into complete silence.
Mhm.
And it stays that way for 45 plus seconds, and then it's broken by the sound of a camera shutter. Beautiful piece of storytelling, absolutely deadly quiet. And if it's not, it's just not the effect they were going. It's almost claustrophobically quiet. It's uncomfortable, and that's really important. So the experiential of why we would do quiet is, I think, based on scenes where there is intentional silence. And if you've got intentional planned silence, is the room quiet enough for you to get that oppressive, uncomfortable nature? Because we're not used to silence. We don't, like, I'm
The
in a room
world
now
is
with,
not silent.
right, the AC or the ventilation in my office is not quiet because I've not put silencers on this. If I go behind that wall, the ventilation is below the threshold of hearing. It's the same ventilation system. One of them's just got a really big, serious, bespoke air silencer on both ends. In this room, it doesn't, because I don't care. But it means that day-to-day silence isn't something we really experience much. But in a cinema, so I would say a cinema should be the quietest room in your house.
Yes, no question. I think at the very least, if you're chasing it in any capacity, you should be able to walk out of your theater and it should sound noticeably different than the rest of your house, in my opinion.
Yeah, it's what I don't like, and this is a thing to understand. It's that quiet and acoustically dead aren't the
Are
same
not
thing.
the same.
So
No.
what I don't want to have that immediate feeling when you walk out of a cinema into a room that has really live acoustics in the rest of the home, and almost have a sense of relief of, oh, that was quite unpleasant in there because it's way over damped. That's not, like, we can do quiet while leaving the life in the room. It's harder. It's easier to get really quiet if you just suck all the life out, sure.
Yeah.
Get absorbed and separate talk, like, easy. But to me, quiet with the life in the room is important. So you don't get that such a stark contrast to the rest of the house when you walk out. It doesn't feel so different if the life is still there, but it should be really noticeable. Like, you should, especially if you stop and think about it. Like, if you sit in any normal room and listen to what you can hear, you'll hear stuff.
There's a lot of stuff.
I don't want to hear that in a cinema.
Yeah, unfortunately, I'm at a limitation in my space, and that is that the projector has to be in the room with me.
Right.
There's no way around it. It's a compromise, right? We talk about this all the time, that if you evaluate what you want the experience to be, then you're able to attack, deal with, or mitigate any compromises that come about. Unfortunately, mine with the projector, it was something that I was not able to mitigate because it has to be in the room. There's not a
Yeah.
separate room. In order to deal with acoustics, I needed the whole room to be open. So it is what it is, unfortunately. That leads me to talk about probably the number one contributor in most people's cinemas, in most people's theaters, to noise is the display in the room. At least a projector.
Yeah.
TVs are
Yeah. If you're
decently
running,
quieter.
absolutely. If you're running projection, it's probably projection. And if you're running, unless it's the very, very latest generations, which run a bit cooler, if you're running a big direct view screen, then there's so much heat, the ventilation of that probably becomes the noisiest thing in the room.
Yeah.
So if you've got a regular normal TV display, you probably don't have a heat problem or a noise problem. But if there's any form of cooling involved from projection or large format direct view, those things are where you're gonna have to mitigate.
So what are some easy ways for people to solve projector noise issues? Hush boxes, obviously.
Yeah, I would say the first thing is projector placement. So we've talked before, I am not a fan of having seats against the back wall.
Yeah.
I see far too many cases where, especially if there's only one row of seats, I know we looked at a room before with one row of seats against the back wall, projected directly above it. That's kind of the worst of all cases. So if you've only got one row of seats, find somewhere the projector's not directly above your head because it's going to be in the middle of the room or the middle of the screen at least.
Mhm.
So it's if it's above someone's head, it's going to be above the best seat. So
Mhm.
definitely keep it as far away as you can. Um, if the projector is okay mounted vertically, mounting it with a mirror mount vertically can completely change the throw ratio. That might mean you can now place it in the very back of the room and have it in a somewhat enclosed section of the room with a mirror mount. That
It can, but to be fully transparent, you are impacting geometry. You're gonna lose some things with a projected image because you are bouncing it off a mirror, and you're not building or buying a mirror that was meant for something like Hubble or this James Webb telescope, so there's gonna be some loss. Uh,
yeah,
I just wanna make sure that
it'd be
people are
really
aware.
minimal.
Yeah.
You have to obviously has to be a first surface mirror. So mirrors work in two ways. The reflective coating is on the front of a glass or on the back of a glass. If you get a regular mirror like you'd use in your home normally, the reflective surface is on the back side of that
Mhm.
glass. That will be a disaster. That's just horrific. It's not going to work. You'll get shadowing and ghosting of that image. So it has to be a first surface mirror. And you can buy lab grade mirrors for not crazy money, like $100, $200 will buy you a laboratory grade first surface mirror that is going to have light loss of under 1%.
Sure. It'll
So
You can, just wanna make sure that people understand that when you put anything in the signal path, you can impact what is going on.
100%. And that will be the same with a hush box. So a hush box to me would be a great option as long as you've done your calculations properly. So
Mhm.
if you just put a projector in a box,
Mm-mm.
give it 5 minutes and it's going to shut off because it's going to just air it out. It's going to overheat. So you need to build it thick and dense enough with a plan to actually properly isolate that noise. But then you need to duct in an air supply and air return to ensure that you remove all of that heat. So it's not straightforward. If you've got like in a lot of spaces, if you're doing say a garage conversion and things, you've probably got some open attic space above that, which means the ducting could be quite easy. You can easily take the ducting straight out the ceiling. You've got options. It doesn't interfere with the room. You can run big ducts. The noise is effectively gone because you can put it above that finished ceiling. The same would be true of the back wall. If you can have ducting come in and out of the back wall. Hush boxes are incredible if planned correctly,
Mhm.
if built correctly, and if you buy them, they're not cheap. So
No.
buying a really good one isn't dissimilar from buying a mid-end projector. They're going to run to thousands of dollars. Um, so yeah, it's not a small decision. You've got to plumb it in. You've got to make sure that it works. You're going to lose some light. Again, I'd hope less than 2%. You should be able to get that to about 98% efficiency. But it's not something that you can just go and build yourself on a whim without properly considering it.
Yeah, I agree. I fully agree. So, projectors are a big issue.
Yeah.
Um, what are some ways with if you've got a room that you're building up from well, before we get into that, what's the next biggest issue that comes in? HVAC?
Yeah, I guess there's two things. There's HVAC and then it could be equal or not will be like noise that's entering a room from outside. So when we talk of sound isolation, there's two parts to that. There's keeping the noise of the system in
Mhm.
and keeping the noise of everything else in the world out. So, like where we are now, I have got 40-ton trucks driving past. We're on an industrial state. I have a train line 50 meters that way. I have a train line 100 meters that way. I have a main industrial road 20 meters behind me. So for us, just traffic noise. I'm in the flight path of two airports.
Mhm.
Like that absolutely is going to be that rumble of lorries for us would be the worst thing. Um, that's really easy if you're in a basement. The likelihood is it's going to be quieter. Um, But I think this is where money is quite well spent. If you're trying to keep out the sound of the outside world, the bonus you get is that you're keeping the system sound in. That changes the acoustics of a space, it changes how you deal with certain things in the room. But to me, it's a real luxury to be able to use that system anytime you want, day or night,
Mhm.
and not annoy the family. So I think that's a real good value for money point on that reduction you make the room quieter and improves your experience, but it also improves the experience of everyone that has to live with you when you want to watch a
Yeah.
film at 2 in the morning. So I think that's a place that spending money is really worthwhile. HVAC again is a challenge. So we want these rooms to be airtight, like completely airtight. Like the
Mhm.
door we'll talk about, but the door's gonna be a really big part of this.
And it's
But
an
once
overlooked part of this in a lot of
Yeah,
spaces.
the door in most rooms that have been well treated is the weakest link,
Yes.
um, because there's challenges around the door. But the HVAC system is a real challenge if it's a shared system ducted to the rest of the house, because you are just giving a transmission path to carry sound straight out into every room of the house, and all the other room, there's vacuum cleaners running, there's stuff happening, just transmit straight through that same ductwork. So ideally, independent HVAC for that room, not linked to the rest of the house.
Yeah.
That
Ideally.
would I right, that's gonna be, if you can do that, if you've got the option. If you're at new construction stage, not sharing that duct with the rest of the house would be
I am a
absolutely
huge fan
ideal.
as well of insulated soft ducting
Yeah.
instead of using, your traditional tin aluminum ducting. It's
Mhm.
far more flexible, far less acoustically transmissive, both in and out. It's very easy to angle because remember, any curves that you can make will
Yep.
slow down airflow and thereby lessen noise, which a lot of times is what silencers do.
Yeah.
Uh, so there are making a room quieter does not necessarily have to be this astronomically expensive endeavor. Sure, it does as you reach end games and you're trying to chase percentage points, but to get tremendous strides, to pick up big differentials in making a in a space quieter, you can do it with not a lot of expenditure, just with a
Yeah.
little bit of forethought and
Right.
trying to think about, "Oh, I probably should do this instead of this," and it
Yeah.
can make a tremendous difference
So, like,
in the long
I've
run.
already said the ducting here is shared through this whole building.
Yeah.
Um, that was just a compromise that we had to make. Now, because I was designing the ducting for the whole building, I designed silencers that we made in-house. They are
Mhm.
DIY homemade silencers, but they were calculated into the design of the whole system. So what's quite important here is if you already have a finished calibrated system, you can't just DIY a silencer.
No.
You're right, because you can I built these silencers for maybe 50, $60 of bits
Mhm.
in total for both the supply and return, and a couple of hours of my time to make them. But if you just add something like that into a system, it's going to change this. Like, this system will have been load balanced. It will have dampers and stuff to make sure that the right amount of airflow is going to the right rooms. You're essentially just completely changing that relationship if you throw a big silencer in. So this isn't something you can just go and do without discussing it with whoever set up the HVAC
I
system in the
mean, you
first place,
can,
or
it
a
just may not be ideal.
yeah. Now, my concern would be if you're in a basement and you do it, you could reduce the airflow into that room significantly enough that you're now not bringing enough fresh air in.
Mhm.
CO2 levels are going to rise, humidity is going to rise. Like, you could make it a really uncomfortable place to be because you're actually now not bringing enough fresh air supply in.
Mhm.
So that relation, like, I don't know where different state building code, we obviously have building code. This is a commercial building. I've got a commercial building code to meet. But if you just put a DIY sound solution in, you could easily push that HVAC system outside of a local building code if you don't understand what you're doing and the ability to rebalance it. So it's not I'm not going to stand here and just say, oh, it's really easy. For $50, you can fix your HVAC, because you need to do the calculations to get it right.
You can
you can, right, 100%. You can if you know how.
Yeah. You can fix it. You just want to make sure that you're doing it correctly. It can be cheap. Just make sure you're taking the time to figure it out. That does not mean, and we'll talk about this in a future episode, that does not mean just asking AI and then going with whatever it says. So
No.
you say
We'll
we'll
do
get
an
there.
AI.
That's not me saying and trying to make this political. It's just, especially with home theater, don't necessarily believe everything that AI says. There's a lot of misinformation out there.
Yeah.
So HVAC, the room. So I don't want to get too extravagant on this. So let's just focus on the basics, like the most common things, like room within a room,
Yeah.
floating floors, insulation, which I think in a lot of capacities is
Yeah.
overlooked. It doesn't, these are all pretty, the room within a room being the most complicated part of one of these, and it's potentially the most expensive because it does take up a tremendous amount of room, but they're not overtly complex in order to implement. It's just space and foresight into thinking about adding them into your space. So if you were going to build a room from the ground up and you were trying to keep some sound in, keep sound out, what do you think is the most important for the construction of the room in what you would wanna do? We're not
Yeah.
talking,
Right.
sky's
So
the limit for finances. Let's
yeah,
talk
absolutely. So
averages
where
here.
I would start, and I've done this with loads of clients, when especially when we're retrofitting, is I want to go and take some measurements in that home. Even if I have a pair of 18-inch subwoofers, but I
Mhm,
take to site for testing. So if we go and put a pair of 18s in the room that's going to be the cinema, and I, play some content and we turn it up, I'll go and take measurements in other parts of the house.
mhm.
So I think the most important thing is to have a target. If you do this completely blind and you don't know what you need to achieve,
Yeah,
it's kind of pointless. So I don't want to overspend on it and achieve, you could spend tens of thousands of dollars and get a result that's way better than you needed. Or you could spend, you might spend $10,000 on a really good sound isolation system, but it turns out it's not good enough to achieve what you wanted.
right.
And therefore, maybe you didn't need to do it in the first
You
place
don't
because
know
you
what
haven't
your
got there.
expectation is, and you don't have to know how to manage those
Right.
expectations, I think is what you're getting at.
Yeah.
So, by measuring, you're able to gauge what your expectation is, and you can say,
Right.
"Oh, I would like it X quieter," or
Yeah.
you may find that I'm fine at this volume, and
Right.
you can just do things to potentially help the room
100%.
in and of
So
itself. So, I
we've
get what you're
we've
saying.
definitely had clients in retrofit jobs where, I've built a 2.2 system in the unfinished room, right? We
Mhm,
crank it up and have other people in the home. So, often be the wife, but could be kids, could be whatever, like whoever's going to use the system, often there'll be other people around the home. So I'll have them go into different rooms and we'll turn the system up. Right. Tell me when this is so irritating to you that you'll be annoyed if the system's that loud. Yep. Okay. We found that level. Okay. So then back it off 10 dB. Is that still really annoying to you? Yes or no? Right. And we can back it off. Well,
now
now I know how much we need to attenuate before other people in the home will be annoyed.
important part there, though, is you need to make sure that you're testing with the correct content, because if I test with something like, I don't know, 2-channel Elton John, just
Yeah,
for
right.
whatever, and then I
I
turn
mean,
on Interstellar into the wormhole, it's
right.
gonna be 2 totally different experiences, and if
Sure.
I'm asking my family to say, "Oh, can you hear this?" and I'm listening to something, you know, mundane that isn't pushing especially the low frequency, you're going to potentially get misleading outcomes.
Right.
So in my opinion, with this, you wanna test with potentially worst case scenarios or
So
whatever you're trying to do.
so we basically already know what that is. So we might as well just say the now official Ben and Ryan official test track for this is Ready Player One, the first race, because
Mm,
it's really loud. It pushes
yeah,
for clipping. It's irritating. It's got bass. It's got high frequency. It's got treble. Right. It's got everything in it, and it's just got some of everything really loud.
I would wanna test something that gets down further into the frequency range. I think that is a great test
Okay.
track, but
So Ready Player One and the opening of Blade Runner 2049.
there you go. Okay, I can get
Now we're
behind
set, right?
now we're set.
Now we've covered everything
Yeah.
down to ultra low frequency up
Now,
to
the reason
irritating noise.
I bring this up, and Ben, I'd like you to enlighten people on this just to make sure that people understand. There is a difference between transmissiveness over different frequencies. So,
Yeah, right.
if we only test with Elton John, why is that misleading? Like, what are your problem frequencies typically when it starts to be an issue in these spaces, especially with sound getting out?
Yeah, so the lower you go in frequency, the more energy you've got to get to the same SPL level. So for it to sound the same level to you, a lower frequency, there's just huge amounts more energy. They're also much longer wavelengths, so they're more likely just to pass. If it's a fairly thin wall, a high frequency, low energy, very short wavelength will hit that wall and bounce straight back.
Mhm.
A really high energy, long wavelength bass note just goes straight through it.
Now,
Barely
typically,
even
what's the relationship, say, with drywall and, like, a wavelength of a given frequency?
oh, you've put me on the spot there. I will check because we don't build walls with single
No,
skins,
yeah,
right?
I don't either, but it it may surprise people at, what frequency things start to become a problem, and it
Yeah,
becomes exponentially more of an issue as we get further and further
right.
and further down in the range.
And
Because
then there's a second problem that is called the coincidence dip. So if you build a wall and you use the same kind of drywall, right? So you use 5/8. Is that a
yeah, it's pretty common.
right? There we go. Right, that's a bald eagle measurement of drywall. So let's say we use that on both sides of the wall. One side we put 2 sheets of it, but it's the same material. There will be a point where you essentially have the resonant frequency of that material, and if all of your material is the same, the resonant frequency essentially just becomes the same. So if you can get one side of that wall ringing, you'll get the other side ringing, and it
Mhm.
makes it much easier for the sound to pass through. So we have software that, as I'm designing a wall, we're layering up different things. It's ideal to use different materials and have it different each side to make sure that you're not just stacking up the same resonant frequency multiple times. And suddenly you can build this wall that behaves incredibly, except a certain octave, everything just passes through it.
Yep.
So it's you wanna have different materials and isolate them as much as you can. So first level of isolation will be staggered studs.
Mhm.
And staggered studs is not a terrible starting point. It's not going to do much against bass, but it's going to take out a lot of that higher end.
To be clear, not much is going to do anything for really low frequencies. It doesn't matter how much money you potentially throw at an issue unless you have the space to deal with it.
Right.
When you start getting really low, it doesn't care. It's just
Yeah.
gonna keep going.
So we're
So
now going
temper
in
your expectations
right,
somewhat.
and we're now talking about that isolation of a keeping sound in to not annoy others. In
Yes.
terms of quiet in the room, that's going to depend on how much noise you need to get rid of, right? So you can do this same test essentially of how much noise can be made in the rest of the house before it distracts me in the room. Now, the rest of the house probably doesn't have 32 or 64-inch subwoofers playing.
Hmm.
Much easier. If you're trying to get rid of a vacuum cleaner or a flushing toilet or the kids laughing, running, playing around, if it's traffic noise from a road that's 10, 20 meters away, that actually needs a lot less isolation to get you
Mhm.
into a nice place than
Yeah.
keeping the sound in. So it's depending on what you want to do and what the goal is, it's not crazy. And there are some things that, hey, there are rooms we've worked in that are essentially beyond fixing economically at certain times. So I have plenty of rooms that have got windows.
Mhm.
When it rains and there is rain hitting that window, nothing we're going to do about it. Just it's beyond economically fixing. The client doesn't want to remove the window. We can't block it up entirely. What do you do about a hailstorm of like
I mean,
just
those are
no
extremes, but I get what you
sure.
mean.
But like at that point, there's nothing you can do to make that room quieter because if you're not taking that window out, the weather is going to be the thing that changes your experience.
Mhm.
So yeah, it's a dedicated room won't have that problem because ideally we're going to block the window up or not have a window. But I would say if you're in a position where the room is always going to have a window, really super maxing sound isolation in your walls maybe isn't the best use of money because you can't control what happens the other side of that window. And
Yeah.
that may be the weakest link that impacts your experience the most.
Now, would you agree that some of the things that you're doing to keep sound out can and do also help with decay times in the room?
Yeah, it'll make it worse. So this problem of like, and it's great. I love seeing this when we go to exhibitions. Like if we go to CDR Expo or ISE
Mhm.
and you hear rooms that have beautiful bass, and then you realize that all of the walls are actually just curtains and there's no physical wall. Yeah, great. You've got no standing waves because all of your bass just left. The the more you contain that sound, so the more dense the walls get, the thicker they get, and the more material you put in that wall to contain low frequency, the more energy stays in. So you're absolutely going to make modal problems like more prevalent
Yep.
if you're keeping that energy in the room.
And this E4 Superfly, this is why I brought that up, is because substrates like brick, concrete, and stuff, while they do help with certain things,
Yeah.
they can exacerbate other things and make it potentially worse. So if I'm keeping low frequencies out, I'm also keeping them in.
Right.
So it's really important, especially if they're not absorbing, right? If I'm not absorbing that material, which is easier to do at higher frequencies, if I'm just providing a reflection point, there's potential to have a really bad time with things
Yeah.
like that. And things can get boomy, bloated, and out of control really fast. Um, and this is an issue in a lot of basements in the US. And I would assume in the UK and things and the rest of the world, because you, as Superfly said, don't build out of paper mache. It's, I would assume, a problem with lower
Right.
frequencies.
So Jeffrey actually made a point on this earlier. You'll probably find this question. If building an addition to a house out of concrete block, still connected to the rest of the house via a concrete block hallway, extra door, do you still need clip hat channel everywhere? Well, it can be really beneficial because what that clip and hat channel does is give some resilience. It gives something that can actually move and be damped. So some of that really low frequency energy, the walls will physically give a little bit on hat channel. If you just rendered the wall and had a finished solid brick wall, there is nothing. It's just a solid
Uh-oh.
put on hat channel and then you drywall it. Is actually you've given something that can have a bit of a benefit, right?
Think
It's
of it like a crumple zone in a car, right? If I
right.
don't have a crumple zone to absorb an impact, all of that transmissive power is going into me or a good part of it. But if the
Yeah.
car absorbs it by moving, and this is something that a lot of people don't think about. One of the best absorbers in anything, if you're catching something, you're moving to absorb that impact. You're not, if I don't move and it just hits me, it's probably going to hurt more and it's going to reflect back the other way. But if I absorb it and more slowly, I'm slowing it down until it's inert. It's very effective, but it's something that doesn't get thought of. in a lot of cases, and as Ben has brought up, is well used or can be well used in a cinema or theater.
Yeah. Yeah, and that's if we're not doing a full room fit out. So if this is a project I'm doing and it's a cinema bureau project, which
Mhm.
includes an officina acoustica interior, we deal with bass in a very specific way in those rooms. If it's not a project with an OA interior, the way I would deal with low frequencies is with a membrane absorber. I almost never try and deal with low frequencies with a rock wall filled big box somewhere, like a velocity based absorber, like rock wall, glass wall kind of thing in a box as a bass trap. They need to be so big that you're just not going to achieve what I'm looking for. But if you use a membrane absorber, that is essentially a box with a rubber membrane strapped to it. Imagine the inverse of a drum. It's like, if I tune a drum skin to a specific frequency, when I play a drum, the other one will move in sympathy to that pressure
Mhm.
and essentially catch some of it.
Now, are you talking about things like Dynamat and any type of absorbative membrane material?
Um, I'll be honest, I buy in tuned membranes. So we buy them as a finished product. I go to GIK Acoustics
Ah,
and I'll know that, right, we know we're going to have a room mode problem at 60 hertz,
mhm.
and I'll have them make me tuned membrane absorbers tuned with a center frequency to 60 hertz. So there's a calculation of how big the box needs to be, what you stuff in it, how thick and how heavy that membrane is. It essentially is a rubber dynamat type product stretched over, like it's just turned into a drum skin.
Yeah.
You stretch it correctly over the right box, you've made an inverse drum, and the hat channel kind of does the same. It just gives you this compliance that can reduce some of those modal effects that you would get in a solid brick room. So yeah,
So,
it's
Jeffrey,
still
the answer is
worthwhile.
yes, that would probably be beneficial for you.
There are
By
definitely
probably, I
benefits
mean
to it.
almost absolutely.
Yeah. Yeah, I would want to do something inside of a concrete block. Like if it's just a concrete room, I don't want just straight concrete walls. I want to
Mhm.
reduce the
No, that
stiffness
would
of
be
them.
awful.
Yeah.
That'd be awful.
The more we can reduce the stiffness, the better.
So, before we go into continuing to talk about the room, I think we need to talk about some other things that contribute to the noise of a space. We've talked about HVAC, we've talked about projectors. What about noise floor of electronics?
Yeah. So I would rarely have the actual electronics in the room.
Mhm.
There are some you just can't put in the room. I mean,
No.
we both know of
Jeffrey,
good
I'm looking
examples,
at
right?
you with that Ascendo infrasonic amp. Good gravy.
I mean, that you just can't put that in the room, right? It's not.
No.
You can't put that in the same part of the building. It's right. It's a really loud fan, but that's quite important actually because I do see a lot of people put their equipment in the room because that's just what's possible. If you're building a regular AVR into a cabinet, you definitely want to be planning airflow around that. Heat kills electronics. If you're
Mhm,
if you're building it into too tight a cabinet, it's going to get hot. If it's got its own internal fans, they're going to start screaming at you. So you can get not expensive particularly, but lower noise cooling. Um, who's the guys that make stuff? I've just completely forgotten their name. I've gone
Who's the
blank.
guys that make stuff?
Yeah, I've just gone completely blank. Who?
AC Infinity?
AC Infinity, right? They've got a range of products that you can sit one on top of an AVR, and it will be quieter than its own internal fans. So if you can use that to get heat away from the AVR before the AVR starts screaming at you with its own
Mhm,
fans going wild, like let's be honest, if you're one of the mainstream processor manufacturers, you're not buying $10 fans. You're going to be using the cheapest, 4-cent fan you can find. They're not built to be as quiet as they can possibly get.
no.
So a third party fan on your processor, if it's got to be in the room, it's
Mhm.
going to serve your investment by keeping the kit cool and be quieter than its own fans if you can
Yes.
keep their speed down.
Yes. And keep in mind that there is a heavy correlation between the diameter of the fan and how much noise it's going to produce. The smaller the diameter, more than likely the louder it's going to be, because just
Right.
like speakers, I have to run that fan faster in order to create the same amount of air movement or air volume movement as a larger fan will. That's why when you get into like industrial applications and you look at ceiling fans, they're enormous. They don't have to move as fast. They're able to slow down. They don't make as much noise. And it's just a lot more efficient. But with that efficiency comes space. And space is at a premium when you're in electronics, and that is a big reason why I'm picking
Yep.
on Jeffrey here, but he knew doing that, so I'm picking on him. That 1U chassis, the reason it's loud is because it has really small fans,
Yeah.
and it's the same for a lot of 1U servers, 2U servers in the compute space. They're loud because they need to move a ton of air. They've got small diameters, and that is just a byproduct of blades
Yep.
moving really, really fast. So
What I actually love about that amp, and I hadn't acknowledged why it does it until I think I may even have read the manual. I mean, I know I need to hand my man card in, but I think I
you
did.
read a manual?
Yeah, I think I did. I think that's where I
Probably
read it.
bedtime reading for
So,
you.
so do you know when you turn that amp on, the fans go wild
Yeah.
for the first 10 seconds? That is done on purpose so that as you turn it on, you hear the fans go wild and you know the fans work.
Yes.
If it doesn't go wild in those first 10 seconds when you turn it on, turn it off immediately because the fans are blocked.
Yes.
It is a safety feature,
It
so
is.
you know they're definitely working.
It is unbelievably loud. It's
Yeah.
shocking how loud some of those things can be. But anyway, um, so we talked about the electronics and fan noise. What
Right.
about the actual noise floor
Yeah.
as it pertains
So
to getting out of your speakers?
right, and this is a trickier one. So
It's not always an issue. It depends. A
right,
big part of it is the sensitivity of your
right.
speaker.
So you've got two things. There's going to be the signal to noise ratio of the amplification and the
Hmm.
sensitivity of the speakers. So hey, we both use quite a lot of Ascendo speakers that are very
Yeah. What are they
sensitive.
known for? Oh, yeah. Sensitivity.
Yeah, they're not known to be slouches, right, in sensitivity. So they're
No.
very efficient. A very small amount of electrical power will produce
Make a big
a
noise.
relative amount of noise.
Hmm.
So then you've got this trade-off of how much noise does the amplifier and the whole signal chain make?
Hmm.
And that is there's two parts to this, right? So you can make very low noise electronics by using very high grade components stuff. It's possible to design it with low noise, but if you have an amplifier which has a lot of power, so we can measure its gain in dB, right? You could take an amplifier and look at it and say, right, this amplifier adds 28 dB of gain
Hmm.
from its input to its maximum output, and we can convert the wattage of it into dB of gain. So if an amplifier is adding 28 dB of gain and the preamp is applying a very small amount of noise, it's got a tiny electrical noise, well, that amplifier is basically applying that 28 dB of gain to it no matter what. The upstream noise is getting that gain applied to it. So speaker hiss is going to become really important. Like that is the worst sound in the room.
And it becomes more of an issue the quieter the room becomes.
Exactly that.
To a
Once
lot
you've
of
dealt with,
rooms, you don't need to
yeah,
worry about it. If you're
right,
chasing quiet, it becomes an issue. And
yeah.
sometimes, like in my room, I can hear the swans because I am on axis with the tweeter. It is what it is. I'm not chasing that. It's a
What do you run
compromise.
them off? What's your amplification on those?
It's a Storm PA16
Okay,
and an
fine,
Altitude 16.
fine.
So
So
I think
you just
part of
need
it is
the
I'm bringing in the noise. A little bit of noise is brought in from the speaker switches.
right.
It is a compromise.
You
But
just
I
need
can
some
it's
of
not
the
just those. I can hear the noise floor from the 64. I can hear some of the noise
right,
floor coming from the 32s.
sure.
So keep in mind, it's not just speakers that have this issue. You can have ultra high sensitivity subs and you could potentially have the same problem.
Yeah. So the Black Swan's a really interesting one of the amplifier that is now recommended as the recommended Ascendo amp to use has significantly less power to the
Mhm.
horn than the main unit. I think it's 10 times. I think it's like
That sounds right.
I might be wrong. It's something like it's less than that, I think. I think it can put out 200 watts. If you bridge it, I think it's like 200 watts into the tweeter and like 800 into the woofer.
While you're talking, I'm gonna see if I can look it up.
You're gonna look it up.
I'm gonna
So
try.
the reason for that is it's intentionally lower gain. You don't need as much power on that tweeter. It's massively sensitive, that compression drive of a horn. So because it doesn't need as much power, don't throw as much at it. Because if you just throw 1,000-watt amp at both sides, you're never going to use more than a small percentage of that on the compression driver. So buy amp it with a smaller, less powerful amp on the more sensitive section. That's the solution on that product. But we definitely see it. And where you see this noise floor highest, and we'll talk about a room being full of snakes because it just hisses at you. If you're using pro audio amps, so I'm not going to like beat up on, well, you know, if you're using like a Crown product because it's low cost amplification,
Great amps,
right? Loads of power, not loads of money. Perfect for certain things. But if you tag that with a really highly sensitive speaker, if you put those on an Ascendo, it's going to be a bag of snakes. It's just going to hiss because that amp was not designed for a really, really high signal to noise ratio to be a low noise amp because they're designed to be used in PA systems, at gigs, in concerts, where the noise floor is massively high in the room because there's 100 people milling around, moving, dancing, right? So it was never built to be low noise. So if you've got really sensitive speakers, you'll need to find out low noise, like search out a low noise amplifier. It's just it might not be the ones you think. There's not a direct correlation between spend more money and immediately get lower noise floor. You're going to balance the gain of how much power do I actually need and not overspec that. What noise floor do I need? The balancing act of choosing speakers with a sensitivity and the amp matches. You could balance that. You could get lower sensitivity speakers and more power amp, or you can balance it the other way. It's when you get it wrong and they hiss, it's really irritating, especially in a high channel count room.
so that amplifier it's not 10 times, but it's no, it is. So at 8 ohms,
Yeah,
you're looking at 140 watts for the high frequency and 1,390 watts for the low
there
frequency.
we go.
So, because that horn, being 117 dB sensitive, does not need that amount of power.
Right.
It is, and this is not just true for that particular speaker. I think a lot of this is true for the majority of speakers, that the higher frequency drivers do not need nearly as much power as the lower frequency drivers due to the power needs to have equal amounts of output at lower frequencies. It's just
Yeah.
not something that's needed.
And when you look at the data of that amp, it doesn't have a better signal to noise ratio on one side than the other.
Mm-mm.
It just has 10 times less power. It has 10 times less power with the same ratio. Well, that means any upstream noise coming from a preamp is being multiplied 10 times less
Mm-hmm.
onto the super sensitive compression driver. So it's not this magically high grade, some lab grade ultra low noise floor.
It's just
It
gain.
just has less power.
Yep. Yep.
That's really important. We
It
will
is.
do an episode specifically on gain structures and how to do that because I think very few people do it. If you've come from car audio, like in car audio, people have understood gain structure for, forever and a day. Home audio, it's just largely been ignored because we
Mhm.
buy an AVR with however much power it's got and we buy whichever speakers we choose, and looking at power and sensitivity and gain and noise ratios just largely ignored.
Let me put some context here. You can be fine without worrying about it in a lot of situations, but if you're chasing the end all, it is something worth considering.
Right. So
So
then
go ahead.
I was gonna say then the real last thing to fix is the door.
The door.
The
Another
door.
thing that is sourly or sorely overlooked.
The problem is you kinda need one,
There are some cool doors, man.
right? I mean, I would love to not have to put a door into that room because the door is a pain in the
Nah,
but kind of most of our clients kind of expect a door.
you do need a
Right?
door
But
most of
we
the time.
definitely need the room sealed because sealed is much better for a
Otherwise, any
ultra low bass. I
sound
don't wanna leave it open.
isolation, audio mitigation, any of that stuff, if you don't have a door, it
Right.
doesn't matter.
Yeah. So, the door is a challenge. Now,
Why are doors a problem? Start there.
so if you go to a high degree of sound isolation,
Mhm,
you're gonna put a lot of mass into the walls, and you've got all kinds of damping materials, and you could build this you could build something that's a foot thick, and it's full of different materials, and it's got insulation in it, it's got damping membranes in it, there's
mhm,
plasterboard, there's timber. Well, when you put that on a door, you've now got to hinge that and keep it square to correctly plug the hole.
mhm.
But because it opens, you now have a rectangular hole and you have a rectangular thing to fit into it. This isn't like the ideal, or maybe this is how we need to build these because we don't now, is like a plain door. A plain door is an actual plug. It can only go in and out one way. It's angled in a way that it seals as a plug.
I mean, that's how my door is.
Is it?
Yes. Well, it's close. It can only go in one way.
Oh,
There's no other.
sure. But, like, we're not currently building doors angled, we build them stepped.
Oh, yes.
So, our doors have we're a normal door, right? So, normal door has the door jamb, and it
Mhm,
has a halfway through the door, you have a timber strip, and a door closes against it, right? That's what stops the door from being able to move both ways. It closes against the door jamb.
yep.
So, you have one interface where the door and the building meet. That one interface is not gonna be enough for me. So we
No.
layer those. I want a staggered, like a zigzag, multi-layer door jamb, and then the door has an exact matching profile.
Not a zigzag. Well, it kind of is. Think of the side of a pyramid where it's stepping like this
Yes,
as it
that,
comes down, and it's like you have multiple door jambs as you go in. So the
right,
door is seating the innermost on the innermost door jamb, then the next one that's staggered out a little bit, then outer, then out, and then out. So you have this stair step as it comes through the
exactly that.
door. Yes.
And each one of those, we'd have a rubber gasket seal on.
Hmm?
So as the door closes, it's now got multiple gasket seals. I'm looking for at least 2 layers of that.
Mm-hmm.
3 to 4 would be preferable, but
Yep.
2 is kind of our minimum. And so where this becomes a challenge again is for local building control, because buying a door off a shelf that's designed
Mm-hmm.
like this is they're massively expensive. You can go and find specific acoustic doors. They run to thousands of dollars. If you're not buying one of those, often what we'll do is like you might start off with a fire door, and then we need to add bits of profile to that to create this shape, or we're cutting it away in a way to make this shape. That could definitely change the integrity as a fire door. It then may need to be recertified. So if your building control has requested a specific rating of fire door, in the UK, they're generally a 30-minute or a 60-minute rated
Mm-hmm.
fire door. If you have that rating imposed by building control, you can't just start cutting and adding to that door without impacting your fire code.
No, but if you're using it for mass and things, it doesn't really matter. It depends on the situation or whatever you're trying to get at. A lot of people will start in the US with solid core doors
Right?
where it's not, paper mache is a commenter made earlier. Uh, because remember, your door in a lot of rooms is the weak point for the amount of mass that is in an opening in a cavity.
Yeah.
And you put all this love and care into these walls, then you put this flimsy door in, and that's a weak point. Audio is gonna traverse that. And
Right.
we'll get to after Ben talks about this, the other thing is going to be pressure and what that can do to the door.
Yeah.
So, sorry for
So
interrupting.
our doors, I mean, let's be honest, our doors are no longer flimsy. Um,
No.
I would need to check a drawing and actually have a proper look at how many layers it is, but we have at least 2 layers of steel inside ours. So
Mhm.
we put steel plate in them. So we have in them steel plate, we have rubber, there is layers of metal. So there's metal, wood, rubber. It's generally got another steel layer, like it could be a steel clad on the outside. It's often up to 4 layers of seal on the top and side and the hinge side.
Mhm.
So they're not like they're hundreds of kilograms, which means you now need hugely solid hinges. Um, and that hasn't fixed the floor because you almost certainly don't want a multi-tiered door jamb on the floor
No.
because it's really annoying when you stub your toe on it. That's like the definition of irritating pain is kicking something like that.
Oh, man.
So that's going to be drop seals, um, a minimum of 1. So as the door closes, it presses a button on the hinge side and it drops a rubber seal out to the floor. Ideally, we'd have 2 of those side by side. So it drops effectively 2 pieces of rubber, and then we have another one that drops 2 more. So we basically have about 4 individual rubber layers. That last millimeter that you can't fix any other way, we're sealing that with 4 rubber strips that drop out of the door and immediately raise when you open it. So they don't drag or sweep the floor. It just drops into place at that last second. Um, that's kind of inevitable. Like that gap around the door. If you've done loads of isolation and you have a 1 mil gap under that door, all bets are off. Everything
Well,
goes in and out of that gap.
yeah, not only about the gap, I've had issues where the low frequency, the pressure has and I have one of those doors. My door's 4 layers, it has multiple locks, was pushing the door out so that if it wasn't seated and pulling itself tight, the door was still rattling like you would see a solid or
Yeah, right.
a light door happen. So it's not just trying to keep the sound in or out. It's also about trying to stop the door from flexing when it's dealing with pressure and creating a noise because we've only talked about the sound. I don't think we'll have time to talk about this necessarily, but you kind of did when you were talking about sympathetic vibrations and resonances where the walls are actually resonating and vibrating against studs. Same things can happen
Yeah.
with doors. If the door is moving, either from pressure or sympathetic vibration from the frequencies, you can run into it moving in the opening, creating its own level of sound and annoyingness. And those, a lot of times, those noises are worse than a lot of the other things because they don't happen at all times, so they're much more jarring
Yeah.
when you pick them up.
Yeah. And so they can come from all kinds of strange places.
Mhm,
So things like if you have a masking screen, you're
mhm.
at some frequency, you're almost certainly going to find the resonant frequency of that masking bar. And there will be one really, really narrow, it might just be a single digit number. It's 119 hertz right there. And it just happens to move that bar so that it rattles slightly in its case. And going in and finding those rattles is really frustrating because you have to just sweep through every frequency and find each one. If you just watch content, it could, you could watch loads of content that never has that very specific frequency in it. And you walk out the room and you've signed it off, and the first thing the client plays, rattle. So you've just got to sweep through frequency by frequency, one at a time, till you make something rattle, go and find it and fix it, make it rattle, go and find it. So that's something to do. Is this an OA door?
Yeah.
Yeah. Okay.
So Superfly was asking for a picture of the door. That's the door. So it's 1, 2, 3, 4 steps.
Yeah.
It's got a couple drop down curtains on the bottom. It
Yeah.
has 1, 2, 3 like of your traditional pop out catches, and then it
Yeah.
has I think 2 or 3 hooks that drop down once the door seats and pulls it
Yeah.
in tight so that it stops it from vibrating. This door weighs over 200 pounds, but swings super easily due to the hinges.
Yeah.
When you stand on the other side of this door, if I'm listening to 2 channel, you can't hear anything through it.
No, nothing at
It's
all.
there the door makes a huge difference. If I didn't have this door, the rest of everything else that I did in this room for sound isolation would be worthless.
Yeah, completely. And so I don't know where that sits in Officina Acoustica's range of, because there's a few different levels of door.
Mhm.
Looking at it, I'm guessing that's nearer the top. But then we go like, has that one got steel plate inside it?
Yes.
Okay, so yeah, it's that's a solid proper
It's
heavy door.
it's a solid door. I remember
Yeah,
having the conversations with Maurizio about it, and then I got it and just went, "Holy crap."
right. Yeah, we're not playing, and
No.
that's what's required of a door once you've done everything else. And especially like, in your room, that 64 plays, the last thing you want is the door rattling in its
It
frame.
will. If it's
Of course
not
it will.
seated correctly, it absolutely will.
Yeah. So
So
you've
that's
got,
why all those latches and stuff are in
yeah,
place.
multiple levels of rubber, and then when you latch that door, it pulls into rubber and it's held against rubber
Mhm.
tight, because otherwise it's going to rattle. Absolutely.
From
I love the fact
experience.
Superfly just said he had to take his door latch apart and glue it to stop it.
Yeah.
Right. There's those things. If you're aiming for quiet, the quieter you get, the more irritating those rattles get, for sure.
Mhm. Yep.
Absolutely.
You start being
Um,
able to name them.
So Big Street said, any issues with electrical outlets and not being airtight, or the cable inside going to rattle. So again, things like this depend on your electrical code. But one of the things that I would always be aiming to do when we're bringing cables into a room is offset their entry points. So if it's a stud wall, I want to come in to the stud wall at one point, cross a stud, so drill through a stud sideways and go into the room, so it is a staggered Z shape penetration. And then when you put your back box in, that back box isn't now going to have a penetration straight out the other side of that wall. The other side is sealed, completely sealed, because you didn't drill in there. The sound has got to go through the stud, but because you've done a Z shape. So that gives you some improvement. But then you can buy things, I think they're called putty pads. So you can wrap the back of a back box in a material to improve the soundproofing, to give it some deadening. And then you can mastic that back box in. You want to be trying to make that back box basically airtight and not have the cable penetration of what it is feeding it going straight through into another space straight away. Like, you want to have, if your building code allows it, it'll be different in every state, it's different in every country. If you can, don't just go straight through that wall in a straight line and have a penetration both sides in the same place. That's less than ideal.
Good question. Anything
But
else
yeah,
you want to talk about?
they're the issues where you go and do all this hat channel and you've built this really nice isolated frame inside, and then you realize you need to cut into it for your light switches, your sockets, all the cables you're bringing in.
Yeah. I had to do that when we were doing the tops in my theater, mainly
Yeah.
because it was a design decision in order to be able to push the speakers up further into the ceiling. Cutting through hat channel is not fun when it's already attached to
Yeah.
the wood. It is not fun. It sucks, but it was done. Not sure how else we would have done it, but it made it work.
Yeah. So
And
in the wall design, it's now a standard part of the walls we build is the last few layers that go into that wall are essentially sacrificial. So we calculate our transmission loss up to a certain point of that wall. And then we have an additional section that's not included at all in the transmission loss calculations, and any penetrations through that. So when we're fixing speakers to walls and we're hanging stuff and we're mounting our frame, all those screw hole penetrations that go through that wall, like these last couple of layers, I'm not worried about sealing every hole, because depending on your contractors, it's so easy. I've seen this happen hundreds of times, right? You're fitting a speaker bracket or something to the wall. In it goes, someone realizes they've fit it an inch out of place, back the screws out, move it and screw it back in. Great, you just left 4 holes straight through that wall. And they need to be sealed as well as the wall that was there, or you've just made holes in the wall. So basically the screw depth final part of our walls and where all the cables run, that whole last bit is completely sacrificial for us. And we are not concerned about how many holes go through it. That's the ideal plan. And we'll always put timber in that. So it will be OSB or ply, ideally marine grade ply, in our sacrificial bit. So we've got a really nice structure to screw things to, that it doesn't matter where you screw, you know you're going to hit ply immediately in that structure. That will take the load. And we know that any holes you make in it, those layers don't really count in our calculations.
Got it.
That's my plan.
Anything else you want to bring to light about quiet?
I'm just reading the questions to see if there's any we missed. I mean, yeah, as Big Street said earlier, he has a NZ 500 1.5 meters behind his head.
Mm-hmm.
That's like,
Could
that
be
is
worse. Not
that's
ideal.
going to be the worst noise in the room for sure. And it's not simple to fix, but it can be done.
Can be. Like a lot of situations, when you throw money at it, if you do it right, they have the propensity to get fixed.
And it's funny, the same Superfly said, when it rains, I can't watch a movie because the noise floor's too high. Right. And that's just the reality of, you know, we actually have it here in Foundry, if upstairs, so we've not done a huge amount of isolation on the ceiling of the building. And when it really rains, and we're in the UK, like when it really rains, it really rains. You can hear that it's less bad in the media room where we have done another ceiling, but you hear that rain coming through our ceiling. That wouldn't be a low noise floor event in that room when it's raining. So yeah, environmental is a challenge when you're designing it. The question from Prince Drama, I don't have an answer to because I've never used it. I wanted to find out if I could use magnesium board mixed with drywall.
Yeah, I don't have an answer for that one.
I've never used it, so I don't know. I'd need to investigate that material and find out. If you have a link to that kind of material, send it to one of us and we'll have a look at it, because we might be missing something that
maybe
we don't use. Yeah, email us one if you've got a spec sheet for it. That'd be cool.
And then Superfly says, Ben, from the outside wall to the inner wall on your projects, what is the thickness?
It depends. So sometimes it's really big. Now, let me think. The biggest I think we've done, maybe 800 millimeters, so 2.5 feet. And so what that will be is that's a concrete box. So that's a concrete brick wall, then an air gap, and then the room is built inside of that. So it's 100 mil or 150 mil concrete floor on springs. So the whole room is now sprung inside the concrete box. Then we build a full steel frame on that concrete floor, and then we build the walls inside that steel frame. So when you're going from outside to in, you've got concrete brick, air gap, insulation, steel frame, then depending on the job, up to about 10 layers of material on that steel frame. And a room like that, you can play as loud as you would ever want, as loud as the system's capable of, but as loud as any human being would ever tolerate, and nobody else can hear it anywhere in the building. Like, you could, you know, it's just and I still wouldn't call it soundproof
Nope.
because there is an amount of noise somewhere that will get through it. We haven't found it, but there is. In fact, I did hear from the guys when we were out in the job out in Asia that at certain really low frequencies, like at the infra level, that even outside this huge amount of isolation, there's a staff kitchen and they could sense vibration in that staff kitchen. Things were like they could sense it, even if they couldn't hear it. When we were pushing, and we were pushing 130 plus dB at 10 hertz, maybe more. And we ran it in for sure. And even with 2-foot thick walls, they could sense it was on for sure.
There's no
So
stopping it. Those
it's
low
not
frequencies,
soundproof.
you're not stopping it. Soundproof to a certain frequency is what I will say, but you get down to a
Yeah,
certain level and
over 25
it's bad.
hertz, that room is maybe. I still can't say soundproof, right? But realistically, over 25 hertz, it is
It does really
impenetrable.
well where it wouldn't really be a problem for the rest of the
Yeah,
house.
that last bit is still.
It sucks.
Yeah, and we tuned the room to 5, maybe a bit lower, 4 hertz, give or take. So
Mhm.
the whole spring construction, it's about an 80 metric ton construction. The whole room will find a resonant frequency down at about 4, and the room will actually then bounce on its springs. So we try and avoid that. That's suboptimal.
It is.
Because if you move it enough, you'll get the point where the projector, which is not sprung, will not like. Yeah, we're trying not to activate that room down at 4 hertz.
First world problems.
Right.
Okay. Well, we will wrap it up from here. Like I said, I'm going to post a link here probably today or tomorrow on YouTube that'll provide a link to a Google form if you'd like to submit your theater for review by the AV Experience. Ben and I, we can go through some stuff. There is an acknowledgement on there that you understand that we are going to be honest. It is constructive criticism. We are not using this in any way, shape, or form to put people down. It is just understand that we're probably going to give everybody constructive criticism and tell no one that their room is perfect, because even the best rooms, there's always something that you look back and go, could have done that a little bit differently, even if it's something minute. If you're not learning and looking
Right.
back at past projects and thinking, man, I could have done that differently, you haven't learned anything. So uh, be on the lookout for that on the YouTube channel. I'll give it to Ben so he can post that as well. And we will go from there. Not sure what the next topic will be next Monday. If you guys have any suggestions, drop them into the comments of the video, not into these
Yeah, there is a
chat.
plan if anyone's interested. I'll have to prep for it a little bit, but there is a thought of doing a review of how good AI is
Yes.
for designing rooms, calibrating rooms. I see more and more people saying,
Oh, I
"Oh, I
asked
did this
AI.
design with AI,"
Oh,
and it might be interesting to do a review of how good it
we
currently
should
is.
build a room
Maybe.
with AI.
No, let's not,
Yeah.
because I can't afford to rebuild it. But maybe we gave away the
No,
answer.
I meant like theoretically put it into a spreadsheet and
Yeah,
this is what AI
exactly that.
said to
Maybe
do.
that's what we'll do.
Yes.
So if anyone's interested in actually doing that, because it will need some prep, maybe we'll do that.
Yes. That's a good idea. But anyway, guys, thanks for joining the show. We do this every Monday. Be on the lookout for those new theaters in review. Again, we have some equipment. You said you have a Barco Freya Plus, if I remember correctly.
Yeah, we sold a client a Nerthus, and we have their Freya Plus we took in part exchange, and I thought I had a home for it, and I'm not sure I do. So
But is it in
I've
the
got
UK?
it's currently in Africa, but we'll send it anywhere.
Okay. And
So
then
I have
I
a
have
really low hour under warranty. I mean, if anyone wants it, give me a call.
I have a what do I have? I have a customer that has a used Storm Audio Fusion. I've got a Storm Audio 32 ISP, and then I have a Storm Audio 16 ISP. So if you have any need for that, shoot us a message, either Ben or I. If you send it to the wrong one, we can forward it and get you taken care of. Again, thanks for tuning in. We'll see you guys in the next episode. Have a good one.
Cheers.
See you
Thank
later.
you.